Hello everyone and welcome back to Study Room. So this is our video lecture number 2 for chapter 2 of class 8 mathematics, that is linear equations in one variable. In this video we are going to learn about the applications of linear equations. What are we going to learn? The applications of linear equations. So we have learned what are linear equations, with one variables, but what are the applications of such equations? Where are these equations used? We are going to find the answers of all such questions in this video lecture. So, the utility of linear equations is in their diverse applications. Different problems on numbers, ages, perimeters, combination of currency notes, and so on can be solved using linear equations. So, if we have some equations or different problems on numbers, on ages, on perimeters, combination of currencies and so on, we can find the solutions for all these problems by using the concept of linear equations. So this is where we can use linear equations. Just take for an example, we are given that sum of two numbers is 74. One of the numbers is 10 more than the other. What are the numbers? So the sum of two numbers is given to be 74. We need to find such two numbers in the case where one of the numbers is 10 more than the other. How do we solve it? Our first step is going to be that we take the smaller number to be x. We let the smaller number be x, the larger number is going to be 10 more than x. What does that mean? It means that the larger number, the second number is going to be x plus 10. What does the other condition says? It says that the sum of these two numbers, that is the sum of x and x plus 10 is going to be 74. So x plus 10 equals to 74. And we get the equation to be 2x plus 10 equals to 74. What is this? This is actually a linear equation in one variable, and we have learned in the previous video lecture that how do we solve this equation? How to get the solution of this equation we have already learned in the next chapter. We are going to just follow the same steps. We are moving all the constants on right hand side. This was our step 1. So it will be 2x equals to 74 minus 10, that is 2x is equal to 64. Our next step in solving this equation will be dividing both the sides by 2. Why? Why 2? Because here the coefficient of the variable is 2. So we'll divide both the sides by 2 and we are going to get the answer 1 by 2 into 2 by x equals to 1 by 2 into 64, that is x is equal to 32. So if one number is 32, the other number is going to be 10 more than 32. That means x plus 10, that is 32 plus 10 equals to 42. So this was what was required. The desired numbers are 32 and 42, and if we add both these numbers, we are getting 74. This is how we solve. This is how linear equations are applied. Now let's do some examples on our own and apply the concept of linear equations in solving all these examples. Our example number 5 is, what should be added to twice the rational number minus 7 by 3 to get 3 by 7? So we have to add something to twice the rational number. So first of all, what will be the twice of this rational number? Twice of minus 7 by 3, 2 into minus 7 by 3, that is minus 14 by 3. We have to add something to this rational number minus 14 by 3. Let the required number, we just let the required number be x. What should be added to twice the rational number minus 7 by 3? That is, we have to add x on to minus 14 by 3 in order to get 3 by 7. So according to question ATQ, when we add x to minus 14 by 3, we are getting 3 by 7. Now we can solve this equation in order to find the value of x. X will be 3 by 7. This is minus 14 by 3. On this side it will become 14 by 3. The LCM is going to be 21. 3 are 9, and then 14 into 7, you can do it in the rough side also. 98. 98 plus 9, this is going to be 107. 107 by 21. Our x is coming to be 107 by 21, and the number that needs to be added to twice the rational number minus 7 by 3 to get 3 by 7 is nothing but 107 by 21. You can just add 107 by 21 and minus 14 by 3. You will get the answer as 3 by 7. So this is how we solved and we applied the concept of linear equations. The next example is example number 6. It says that the perimeter of a rectangle is 13 centimeter and its width is 2 is to 3 by 4 centimeter. We need to find its length. We know that the perimeter of a rectangle is given by the formula. The perimeter of a rectangle is given by the formula 2 into length plus width. Here L is length. Here L is length and W is width. This is given as the perimeter is given to us, that is 13 centimeter, and width is also given. So here perimeter is given to be 13 centimeter. Width, that is W, is given to be 2 is to 3 by 4, or we can write it as 4 2s are 8, 9 and 11 by 4 centimeter. So W is 11 by 4. This perimeter is 13. We need to find L, that is length. This will be 2 L plus, put the value of W, it was 11 by 4, which is equal to nothing but the perimeter, that is 13. Now we are going to divide both these sides by 2. It will be L plus 11 by 4 is equal to 13 by 2. And in order to find L, we'll take 11 by 4 to the other side. It will become minus 11 by 4, and this is going to be 4. 26 minus 11, that is 6 minus 1. 5 and 2 minus 1, 15 by 4. So what is our length coming to be? Our length is coming 15 by 4 centimeter, or we can write it as 3 is to 3 by 4 centimeter. 4 3 is 12, 13, 14, 15 by 4 centimeter. So this is what we had to find, the length of the rectangle where its width was 2 is to 3 by 4 centimeter and the perimeter was 13 centimeter. So you have to remember the formula of perimeter of rectangle in order to find the solution of this equation. It was 2 into length plus breadth, or length plus width. Next example is example number 8. It says that the present age of Sahil's mother is 3 times the present age of Sahil. After 5 years, their ages will add to 66 years. Find their present ages. So we're letting present, so let the present age of Sahil X years. So the present age of Sahil's mother will be how much? It will be 3 times the present age of Sahil, that is 3x. After 5 years, their ages will add to 66 years. So I'll write after 5 years. Okay, after 5 years, age of Sahil will be how much? Age of Sahil is going to be how much? X plus 5 years. Because if right now I am 3 years old, after 5 years I will be 3 plus 5, that is 8 years old. So similarly, the age of Sahil after 5 years is going to be X plus 5, his present age plus 5. Similarly, after 5 years, age of Sahil's mother is going to be how much? Her present age, that is 3x plus 5. Now after 5 years, their ages will add to 66 years. That is, if we add the ages, these ages, that is, if we add x plus 5 and 3x plus 5, we will get how much? We will get 66. We need to find their present ages, that is, we need to find x and 3x. We'll solve this. It will become 4x plus 5 and 5, 10 is to 66. Take the constant to the other side. It will be 4x is equal to 66 minus 10. That is 56. 4x equals to 56 and x will be equal to 56 by 4, or you can say that it will be equal to what? X will be equal to 14. X is going to be 14. What was x? Therefore, we can say that Sahil's present age, or directly Sahil's age, equals to 14 years. 14 years, that is x, and Sahil's and his mother's age is, his mother's age equals to what? 3 into x, that is 3 into 14 years, or we can say 42 years. This was what we had to find their present ages. So we started this and we concluded and said that the present ages of Sahil and his mother are 14 years and 42 years respectively. Now we have one more example, that is example number 8. We are again going to apply the concept of linear equations. So it's written that Bansi has 3 times as many 2 rupees coins as he has 5 rupees coins. If he has in all a sum of rupees 77, how many coins of each denomination does he have? So it's written that Bansi has 3 times as many 2 rupees coins as he has 5 rupees coins. Again read it. What is it written? That Bansi has 3 times as many 2 rupees coins as he has 5 rupees coins. So let number of 5 rupees coins be x. Bansi has 3 times as many 2 rupees coins as he has 5 rupees coins. So the number of 2 rupees coins will be 3 times x. Why is that so? Because it's written that Bansi has 3 times as many 2 rupee coins as he has 5 rupees coins. So if 5 rupees coins are x, then 2 rupees coins are going to be 3 times this, that is 3x. That is what I have written here. If he has in all a sum of rupees 77, we need to find the number of coins of every amount, okay? So if he has in all a sum of rupees, now total amount he is having, amount of rupees 5 coins will be 5 into the number of 5 rupees coins, that is x, and the amount of rupees 2 coins is going to be 2 rupee coins is going to be 2 into the number of 2 rupees coins, that is 3x, that is 3 to 6x. This is the total amount, and the total amount is going to be rupees 77. That is, if we add 5x and 6x, we'll get 77. We just have to solve this equation and we'll get the required answer. This is going to be 11x equals to 77. We need to divide both these sides by 11 and we'll get 77 by 11, that is 7. So the number of 5 rupees coins is x, that is 7, and the number of 2 rupees coins that he have is 3x, that is 3 into 7, that is 21. So he has total 7 number of 5 rupees coins and total 21 2 rupees coins. This is what we had to find. How many coins of each denomination does he have? Our next example is example number 9. The sum of 3 consecutive multiples of 11 is 363. Find these multiples. Okay, so we know that if we have taken first multiple of 11 to be, let first multiple of 11 be x. If we write the first multiple of 11 as x, what is the other consecutive multiple of 11? The second consecutive. Consecutive means just like the together, not having any gaps. So the second consecutive multiple of 11 will be x plus 11. The third consecutive multiple of 11 is going to be then x plus 11 plus 11, that is x plus 22. So these are the three consecutive multiples of 11. Now it's written that the sum of these consecutive multiples is 363. That is, according to the question, x plus 11 plus x plus 22 is given to be 363. We need to find these multiples. So how will we solve? When we are adding these, we are getting 3x plus 33 equals to 363. That is, take the constant to the other side, 363 minus 33. That is 363, you can do it on the rough side. 363 minus 33 is going to be 330. 3x. Now we need to divide by the coefficient of x, coefficient of the variable, that is x, that is 3. We will be dividing both the sides by 3. We will get 330 divided by 3, that is 110. What are we getting? We are getting x, and x equals to 110. What is our next number going to be then? So first multiple is x, that is 110. Second multiple is x plus 11, that is 110 plus 11, that is going to be 121. The third multiple is going to be x plus 22, that is 110 plus 22, that is going to be 110 plus 22, that is 132. So these are the three consecutive multiples that were required. So we went on by doing, how did we solve it? We took one multiple to be x, the other consecutive multiple was going to be x plus 11, and the third one was going to be x plus 22. All these three numbers, sum was given us to be 363. We solved and we found out the value of x. The other multiples will be given by x plus 11 and x plus 22. So the three multiples that we had to find are 110, 121 and 132. Our next example is example number 10. The difference between two whole numbers is 66. The ratio of the two numbers is given to be 2:5. What are the two numbers? So we can write, if the ratio is given to be 2/5, then we can write the first number. Let the first number be 2x. If first number is 2x, then the second number will be 5x. You can check that the ratio of 2x and 5x is going to be 2:5. So it is satisfied, okay? So first number is 2x, second number is 5x, and the difference between these two numbers is 66. So according to the question, 5x minus 2x is given to be 66. Now solve this. 5x minus 2x will be 3x. This is equal to 66. X will be 66 divided by 3, that is 22. So we have to find the two numbers. So we have found out. Now just be careful, we have found out the value of x. This is not our number because the two numbers that we had to find are 2x and 5x, not x. So our first number will be now, x is 22, so it will be 2 into 22, that is 44. And what is our second number? Our second number will be 5x, that is 5 into 22, that is going to be, you can do it on the rough fork, 22 into 5, that is going to be 5 to 10, 5 to the 10 and 110. So our two numbers are 44 and 110. And when you be finding the difference of these two numbers, 110 minus 44, your answer will be 66. That is what was given in this example. Our next example is example number 11. It says that the Veshi has a total of rupees 590 as currency notes in the denominations of rupees 50, rupees 20 and rupees 10. The ratio of the number of 50 rupees notes and 20 rupees notes is 3:5. If she has a total of 25 notes, how many notes of each denomination she has? So we need to find the number of notes of each of these denominations. What is given? That the ratio of the number of 50 notes and 20 notes is 3/5. So we can let the number of rupees 50 notes be, we can let the number of 50 notes be 3x. We can let the number of 50 rupees notes be 3x, and then the number of rupees 20 notes will be 5x. You can check that 3x ratio 5x is going to be 3:5. This is what is given in this question. Now if the number of 50 notes is 3x, if the number of 20 rupees notes is 5x, if she has total of 25 notes, so what is going to be therefore the number of, last one is rupees 10 notes, is going to be 25 minus 3x minus 5x. So if we minus the number of 50 rupees notes and the number of 20 rupees notes from the total number of notes, we will be getting the total number of the 10 rupees notes. So since total number of notes are 25, we will just subtract the number of 50 rupees notes and the number of 20 rupees notes from it, and we will get 25x minus 5 and 3, 8x. So this is the number of 10 rupees notes. It is 25 minus 8x. Now it is written that Deveshi has a total of rupees 590. The total amount is rupees 590. So what is the amount? What is the amount of rupees 50 notes? The amount of rupees 50 notes is going to be 50 into 3/x. That is 150x. 50 into 3/x. That is going to be 150x. The amount of rupees 20 notes is going to be what? Is going to be 20 into 5x. That is 100x. And the amount of rupees 10 notes is going to be what? 10 into 25 minus 8x. 10 into 25 minus 8x, that is 250 minus 80x. We are multiplying 10 with both these numbers, both 25 and 8. We will get 250 minus 80x. So these are the amount of respective notes. It's given that she has a total amount 590. That means we will add all these amounts, are going to get rupees 590. According to the question, 150x plus 100x plus 250 minus 80x, this thing is going to give us 590. What will it be equal to? 150 plus 100x, it will be 250x minus 80x is going to be, just take the constant to the other side, it will be 590 minus 250. This is going to be, subtract 80 from 250, 250 minus 80, this is going to be 170x. And this is going to be 590 minus 250, that is 340. When you solve 170x equals to 340, you are going to divide 340 by 170 and you will find that x equals to 2. What was our x? X was nothing. X was just a variable. We at last, what do we have to find? At last you can check that the question asks us the number of notes of each denomination that she has. So we know that the number of 50 rupees notes is 3x. So what is 3x going to be? We have found the value of x, not the number of notes of 50 rupees. It is 3x. It will be 3 into 2, that is she has 6 notes. She has 6 notes of rupees 50. She has 5 into 2, that is 10 notes of rupees 20, and she has 25 minus 8x, that is 25 minus 8 2s are 16, that is 25. Just subtract it. What is 25 minus 16 going to be? 9. So she has 9 notes of rupees 10. This is what we had to find. We had to find the number of notes of each denomination she has. That is, we had to find the number of notes of rupees 50, number of notes of rupees 20, and number of notes of rupees 10. That is 3x, 5x, and 25 minus 8x. We found out the value of x. We put the value of x in all these expressions, and we found out the number of 50 rupees notes, 20 rupees notes, and then at last the number of 10 rupees notes. This was all about our video lecture number 2. In the next video, we are going to solve equations having the variable on both the sides. So, we will learn how to solve equations that have variable on both the sides in the next video. Till then, have a good day. Take care. Bye bye.